The landmarke vision describes a system which does not focus on precise locationing, but on providing navigational support which builds on the existing skills of firefighters. During the mission, the firefighters themselves deploy the nodes of an ad hoc, self-organizing WSN as they find it the most useful. This system provides navigational support by using the deployed nodes, also known as landmarken, as waypoints to navigate to important places and to track firefighters moving along the nodes. Landmarken further allow the storage of tactical information. They mark special places and can indicate which spaces have already been searched or which haven't been explored yet. While exploring the fire field, firefighters further collect knowledge about their environment and synchronize their knowledge with fellow comrades to complement their view of the scene. Implementing this vision requires an architecture which supports different types of network sensor nodes, a data storage which enables binding information to these nodes, and, to accommodate all types of firefighter brigades, a flexible architecture. The requirements were realized using 6LoWPAN as network technology, connecting two different types of devices, the firefighter device and the landmarke node. In our first system demonstrator, we used a Linux-based smartphone as firefighter device. Thereon, a model view controller architecture was implemented to handle data access and allow a flexible coupling of fire brigade-specific components. An object-oriented model was selected to represent the individual knowledge of a single firefighter. As you can see in this simplified model, some natural relations are represented. For example, a troop typically consists of 2 or more firefighters and it usually has 20 landmarke nodes. The object-oriented model also enables simple synchronization between the knowledge of 2 firefighters. The components which we connected to the firefighter device are the in-mask awareness, a wearable display, an integrated control bar for changing landmarke status information, and finally, the GENIC integrated microcontroller and 802.15.4 transceiver to which we ported contiki. Around this microcontroller, the landmarke node was built. It is outfitted with various actuators and sensors. The node was then integrated into this wedge-formed housing, replacing the wooden wedges in the regular firefighting equipment. After implementing the prototype, we evaluated the system together with the firefighters. We explored the handling properties of the landmarke nodes and their fixation possibilities. The idea of the wedge form, which allows a perfect integration of the nodes into the work practice, was also developed during one of these workshops. We further analyzed the possibilities of the in-mask awareness and how information can be represented without distracting the firefighter from his job. Studies regarding the wearable display and how to visualize more complex information in an understandable manner were conducted. One of the key features of the system is the possibility to rediscover landmarke nodes. With the prototypic system, we conducted tests regarding optical rediscovery, especially regarding LED luminescence and blink frequency, acoustical rediscovery, regarding frequency and tone sequences, and radio-based rediscovery, in respect to antenna type and antenna placement on the firefighters for best results. The presented architecture consists of a heterogeneous ad hoc WSN, a model view controller design pattern, and an object-oriented data model. It worked well in a complex test with 10 connected landmarke nodes in proximity of the firefighter device and various connected views. The use of technologies like 6LoWPAN and the framework Qt allowed a desktop-based system design and seamless porting to the embedded device, thus enabling the quick incorporation of suggested features. The first integrated demonstrator of this specialized tracking application was found useful and yielded positive and highly motivating feedback from the firefighters. The possibility of a brigade and mission-specific configuration and the potential to replay missions, both implicit in this architecture, increased the system's value for the end user. Hence, this architecture seems suited to realize the landmarke vision and to make firefighting a safer job.